Hello, everyone, and welcome to this live stream. This is Snyk Live, part of the Log4j series, and this session is what has the Log4shell vulnerability taught us about application security. So, joining me today is Gaipo, founder of Snyk. Gaipo, how's it going?
Going well, kind of crazy days, but great opportunity to provide value. So going strong.
Absolutely, yeah. It's been a tough week, and my name's Simon Maple. I'm the field CTO here at Snyk, and yeah, today we're gonna cover a number of topics. But first of all, why don't we do a little bit of a TLDR of Log4shell to start off with, and then talk about maybe what are some of the core actions that you need to take if you haven't taken them so far. So, Guy, why don't you tell us a little bit about Log4shell?
Yeah, for sure. So if you're probably most people tuning in right now have heard of it a fair bit, but in summary, Log4j is a very popular library in the Java or sort of JVM world, used for logging, for log messages, keeping track of activity that happens throughout the system. It's quite robust and very kind of widely used, has been for many years. So really, not a distant statement to say that pretty much every Java application, or really the vast majority of them, are using Log4j. Log4j has introduced a capability in Log4j 2 that allows it to do JNDI lookups, which, in short, not to sort of make this a JNDI tutorial, allow a carefully formatted message to make the logging action go and look up some information in a remote server, notably an LDAP server, and get back either some information or sometimes even some code that gets evaluated locally. This is capability it's very minimally used, but was a convenience. It seems to be sort of a convenience functionality to log things like application names or context or things like that, and just methodically add them to log messages. Unfortunately, that capability was on by default, and one of the areas that it can kind of go up and do is to go to an LDAP server and download an actual piece of code to execute locally. And so by being on by default, the effect of it is that if an attacker can get user input into a log message, and that message is crafted in sort of a specific format, but fairly simple, like a dollar curly bracket, JNDI colon, LDAP colon, then and provide an evil server over there, the system in question, Log4j, would actually go off and look up that object and execute the code locally, making this a remote command execution. And the kind of the last bit that's quite makes this even more severe. We already talked about the fact that the library is very prevalent, so that's one aspect of it. The fact that it's remote command execution is the second. The exploit is very easy, and not only is it for an attacker, it is actually just very, very likely that you are logging user input. It's very common. You got some bad input, you might log it in an exception, you might log it as part of just noting that user X has done Y on a system. And also, even if you're using this library in a very nested fashion, you're using some component that uses a framework, or using a framework that uses some component that uses Log4j in it, it's likely that there is logging that happens all the way through that deep channels. And if any one of these systems logs user input in raw format, it can trigger a remote command execution. So all of those different variables have multiplied together to something quite explosive when you think of just the very, very broad reach of everybody pretty much using Log4j, the severity of the vulnerability, and the ease of exploit that really multiplied into what is probably the most severe vulnerability, definitely of the decade. Maybe, it's always like sometimes feels like hyperbole a little bit, but it doesn't matter if it's top 1 or 2 or 3. It's definitely the most, or one of the most, vulnerabilities that we've sort of seen around the internet.
Yeah, and I think we'll do some comparisons with other vulnerabilities, such as potentially the struts vulnerability, and also maybe SolarWinds a little bit later. But I think one important thing to say right now is, if this is an area that you haven't looked into just yet. I'm sure you're all on it, but if not, obviously the current remediation advice is to upgrade Log4j core up to version 2.16.0. And originally it was the fix for the remote code execution was added into 2.15.0, a release candidate 2. But it turned out, in hindsight, it didn't completely fix the issue, and actually there was a separate vulnerability which was raised a couple of days ago, which is a denial of service. So this is also fixed in 2.16.0, which actually disables the JNDI by default. So 2.16.0 is the version that you want to upgrade to. Guy, tell us a little bit about some of the differences between a direct dependency here and a transitive, and how that's also causes problems for doing these kind of upgrades.
Yeah, for sure. Just one small qualification on the 2.15, 2.16. If you've already gone through the sort of effort of upgrading to 2.15, you should prioritize working on the rest of the systems and upgrading them to 2.15 versus going back and changing to 2.16. Yes. It is dramatically less severe. There's a lot of debate about the vulnerability between 2.15 and 2.16. If you are just upgrading, you might as well go all the way to 2.16 and be a bit safer. But yeah, definitely prioritize getting everything to 2.15. That's the big jump, and then there's a smaller jump that happens after. The transitive dependencies is an interesting problem. So just think a little bit about Log4j. So it's been around for a long time in the Java world. It is very fit for purpose. It's a great library for logging. It's very tried and true. It's already connected to a lot of different frameworks, and so over the years it has evolved to be consumed in many different ways, and it's embedded. It comes with a bunch of different frameworks, or sometimes you can even enable it from the outside. You have systems that can log in various ways, and you can configure environment-wise or with other settings. That Log4j will be the library of choice through which you would audit. And so when you are seeking out the instances of Log4j, this is definitely a time to it's not good enough to just look to see if your application, your individual application, directly uses Log4j. You really need to look for other ways in which that library was included. In context of the code, one of the most common kind of paths that it might have been included and that you should cover is what's called a transitive dependency or an indirect dependency. You are using a library, you're using struts, you're using Spring, and in turn, in the case of Spring, it's a bit more configuration dependent, but that library might use Log4j. And so the trick is that you really should vet if you're using tools to assess whether you're using Log4j or not. A lot of the open source tools and a good number of the commercial tools, they do a very valuable first step, which is they look at your manifest files or at the files you consume directly, and they say, am I seeing Log4j and the vulnerable version within them? But many of them, if not most, do not do the somewhat elaborate process of trying to now take each of these libraries they found and assess whether they in turn use other libraries or which libraries they use. When we look at our data at Snyk, we see that actually 60% of the applications that we scan use Log4j indirectly. And so simple statistics, out of 10 applications that you might assess, if you only look at those direct dependencies, you're going to miss 6 out of 4 uses of Log4j. And so it's important for you, you really need to confirm that you are using a solution. We're sort of a bit, Snyk, clearly I can tell you that Snyk does it. Snyk is not the only one that does, but just sort of pick a solution that gives you that indirect assessment. A slight, I know, Simon, we're sort of talking about transitive dependencies, but this is sort of a part of a bigger picture, which is, in general, you should try and assess for Log4j usage in various ways. 2 other important ways in which you might be consuming it. One is Log4j can be installed via the operating system dependencies. You can install it through apt, you can install it through a variety of ways. And so if you're using containers or VMs, assessing those to see if Log4j is installed is just as important, because as we mentioned before, Log4j might even be included without like as an environment, like a set logging mechanism. So make sure you do that, and this is probably like in decreasing kind of lower of probability. First, check your code and translate dependencies to do it. Second, check for the operating system just in terms of likelihood of how it was done. And then the third is to look for the actual files in your file system, because of the sort of the history, or because of the way the JVM and Java world works. It is a fairly common occurrence for people to just download those libraries and just sort of use them, in a raw format, just sort of vendor them or embed them into the systems. And so looking through the file system to assess whether those files with Log4j exist there as a manually downloaded file is very important as well. But I'd say, you have to prioritize in some fashion. So per the stats that we're seeing, that's probably the order of urgency through which to try and assess your use of Log4j, right?
Yeah.
And there's the whole world of shaded jars that, Simon, you can probably explain better than I do, which that last bit touched on.
Yeah, and shaded jars, the jars can be shaded in a number of different ways, and sometimes you might just consider renaming a jar file, for example, or maybe pulling jar files in other jar files, exploding those jar files in other jar files. But there are ways in which it can be a lot trickier to identify that you are using Log4j because it doesn't appear in the standard Log4j form. So it's another way which makes it a touch tougher for tooling to be able to actually determine whether that's the legitimate Log4j, and also at what version that Log4j instance is. There's an interesting question that's come in here from Davis Peter, which I'm going to show. And I think this is question is, can an indirect dependency cause exploitation of Log4j? And I'm guessing this question is really if there's a Log4j instance that exists in your transitive dependency graph, is your application still exploitable? That's how I'm reading this question. And I think the answer to this is largely, well, there are two things that are important here for this application to be exploitable. First of all, the exploit is it's open by default, in the sense that Log4j, if it tries to log a specific string which looks like a variable lookup essentially of a JNDI location, it will go out to that JNDI location and it will try and pull back whatever object you're trying to refer. So the big question is, how can you, from the user point of view, get to a stage whereby that your malicious, your attack string, that payload, is being logged? Now, whether your dependency is direct or transitive doesn't matter too much. It more matters whether you can get the attack string to that. Any thoughts, Guy, on whether there's priorities in terms of, or rather higher risk, if it's a direct versus transitive in your experience?
Yeah, I mean, I think so. It's a good question, and in many vulnerabilities, the answer to that is indeed, if it is indirect, it is less likely to be exploitable. In the case of Log4j, it absolutely can be, and is pretty much just as likely to be exploitable if it is direct or indirect. For instance, if you're using a third-party library that makes an API call into Facebook or Twilio or something like that, or to like any social network, for instance, right, through a library, and you pass along the user agent so that the library in question can identify that to get some JavaScript snippet or something like that to put on your page back. If that user agent is passed on to the library, it's actually reasonably likely that the library logs it. Not only is it likely, it's oftentimes required when you are using libraries or frameworks. Logging what happened inside is oftentimes the only way in which you, as a consumer of a library, have visibility into what happened. Like you made a call, the call failed, or didn't produce the result that you want. Typically, the first action that you would do is you would go to see what are the debug logs, what are the information logs, what was logged to indicate what was the problem. And so those third party, those libraries, those frameworks you use, not only are they likely, they are expected to log what has happened, and especially in error cases and exception cases, they would very often log user input. And so in this case, it is basically identical, basically just as likely that an indirect Log4j use would be exploitable as a direct one is.
Yeah, and of course it doesn't have to be an error case, although if it tends to be more in
Yeah.
error cases. Otherwise, your logs can absolutely fly depending on how busy your sites and transactions are. But yeah, it tends to be the way that people look to exploit this. We've got a very interesting question from Gerald here about compensation of maintainers. I'd love to, if it's okay with you, Gerald, I'm gonna push that a little bit back to where we're going to be talking about open source groups a little bit later. One question that has come in a couple of times, Guy, and I think it's worth just not clarifying, but being very explicit about this. The question is Snyk and operations at Snyk vulnerable to Log4j? How has that gone down here locally?
Yeah, so we're, very valid question, and we're not immune. When these vulnerabilities, when we find out about them, when we use them, we're the first ones to sort of assess whether we are exposed. So generally we feel like we are in very good shape. We have immediately assessed the applications that we have to see if they are indeed exploitable to it. In general, at Snyk, we are not a big Java shop. So we don't use Java as much, which reduced a certain amount of our exposure, but we do use certain third-party applications that use Java, and we have a little bit of use of it. So we immediately assessed it, and we officially confirmed that within 24 hours of the publication of it, all the services that were touching Log4j have been patched to the latest version, and that we have not detected any attempts at exploitations for us. We're further reassured by the fact that in our specific case, most of those services weren't main services of the application. They were test services or side applications that help our team. But it's a valid question, and just to say that in general in Snyk, in terms of core practices, we're our first customer. We sort of the first thing we assess is whether those components affect us, and we're very quick to address them.
Yeah, and great reassurance, and thank you for the update there. It saddens me a little bit that after 4 years of my employment at Snyk, we still haven't really pushed into the Java world in terms of our own implementations. But hey, that's more indictment on my ability to.
One might say that's a live debate, Simon. I mean, there's definitely some Java champions in all senses of the world. We love all programming languages. We just choose to use some of them a bit.
Yeah, sounds good. But no, a big hug ups to everyone out there who I know are working nights, working weekends, and everything to get this done. So amazing jobs to everyone who's putting all that extra time in, and keep going. We'll get through this together. Let's talk a little bit about the background of this guy. I'll walk through a couple of stats, and then we'll talk a little bit in more depth about it. So, way back when, the idea of an attack vector against a JNDI instance, whereby the idea of doing remote JNDI lookups can potentially affect your application with third-party user input, was discussed actually 5 years ago at Black Hat in a session. This specific vulnerability, which was found in Log4j, obviously, was found by Alibaba's cloud security team, specifically Chen Zhaozhang, and they disclosed to Apache in late November. So this wasn't news to Apache on the disclosure date of December 10th, which was the public disclosure date. This would, Apache had some time to look at this in the past. Now, interestingly, I believe it was Cloudflare that mentioned that they noticed an attack in December 1st, which was very, very interesting, given that it took another 9 days for this to be publicly disclosed. So I guess, Snyk, as a company that also does disclosures, does responsible disclosures, private disclosures, in fact, has worked with the Apache Foundation as well through one of the big disclosures that we did, ZipSlip, recently as well. Let's talk about how these things can get leaked. Or actually, first of all, how do you feel the disclosure, I guess, process has gone for Log4shell?
Yeah, so disclosures are tricky, and it's awfully easy to point fingers. And so, for starters, I would just sort of say, generally, almost all people in these flows, they're doing something good, right? Either they are finding a problem, they're not going to get compensated for it. It's an open source project. They've done the work. They volunteer that information versus keeping it to themselves, so the community can be secure. And of course, the open source maintainers themselves are doing all of us a great service, especially for these popular libraries. And it's a fairly ungrateful job. And so we have to remember in all this context is it's almost never malice. It's never ill intent when mistakes happen, and they are tricky. In this case, I'd say the initial disclosure was great. It was privately disclosed to Apache as a in a private fashion, by the Alibaba Cloud Security team, which is the way it should be. They've been announced. I'm not sure all the specifics about who worked on it before, but at the end of the day, a fix was available at the time of the official disclosure, and so that part worked well. The fact that there were attacks that sort of slipped in, before that, that's just a bit of an unfortunate reality. There are many reasons to it. Of course, there's one, which is it could be that certain attackers have some form of access to some Apache maintainers' information or some system there. That could be, it's a possibility. It's also possible sometimes attackers listen on networks and on network activity and try to find attack patterns and reverse engineer them in order to identify flaws. So that could be the case. And it could also have been a misdetection on Cloudflare. Like, all of those are possible. We don't really know, but information is never fully private. In general, this was a reasonably fast disclosure between the disclosure time and the time in which a fix was done, right? We're talking a couple of weeks, roughly. The tricky part really is when you disclose, who is it that you disclose to? So in this case, the researcher disclosed it to the owners of the library. The library maintainers fixed it and then publicized it. And at the same time, the researcher published an exploit for it, demonstrating it. So none of that is flawed. The problem is, if they were reporting, say, a vulnerability to Snyk or to any kind of company, any SaaS company, telling them there's a vulnerability there, the point in time in which it might have been disclosed or sort of shared, if at all, would have been at a time in which the systems were already fixed. In the world of open source, there is no official registration of who is using that library. So these Log4j maintainers now, they have this vulnerability. Let's say they fully acknowledged the severity of the problem, and they want to alert everyone to fix it. They actually have no standard way of saying who is using Log4j, no standard vehicle to reach out to them. It's not like a vendor that might have a list of contacts or customers to email, and so it's not obvious what is it that they should do to actually address those problems. What we've done, sorry, Simon, you were going to say something? Or?
No.
What we've done at, for instance, when we disclosed ZipSlip, so ZipSlip was a vulnerability that the Snyk research team has uncovered and disclosed to a variety of projects that had it. It was tricky because it was this bulk disclosure. You wanted to tell multiple library maintainers about this, but because you didn't want attackers starting to exploit those, we asked all of them to keep it quiet and oftentimes not even fix, hold on to the knowledge of the vulnerability, write the fix, but write it in private, and then try to coordinate the publication of all of those fixes. And we tried to coordinate with some key applications that we knew to be vulnerable because we knew that they are using the vulnerable libraries, and we manually, and we invested significant amount of time at finding those in this case, a lot of them were specific applications, finding them and reaching out to them. We did the same with we had this whole issue with Sourmint, which was a malicious SDK we uncovered. Similarly, we found applications, we reached out to them. Those are painstaking, time-consuming processes, and even then, they are not fully exhaustive. You wouldn't find everybody that uses it, and so at a certain point, you have to open up and just tell the world, here's a problem, here's the solution, you need to go. And you need to say that the responsibility at that point is on the consumers of open source to be ready, to keep track of the inventory of which components they're using, where they are, and be as ready as they can be to apply those fixes.
And yeah, I remember very, very clearly actually, because I was also involved in Zip Slip, and the sheer amount of work, the manual lists that need to be created, then trying to work out where the emails needed to go from. We did a lot of work with Apache to try and make sure that, you know, their major projects, they were working with their maintainers to fix those as well. There isn't a clear path as to how to do this. So if you're not, you know, we have the benefit that we are a security company, right? And we are able to understand how we can kind of release this in the wild with as little, I guess, you know, problems as possible to developers who are going to be consuming that. But I think it is interesting that I feel like our industry does need a more well-defined path to deal with these as well, because, you know, you end up with this race condition where you don't want your attackers and your defenders to effectively start in the same place. You want your defenders to kind of be chased by the attackers in the sense that they have the head start, rather than the attackers absolutely fly and, you know, through automation, etc. They're just spamming sites trying to identify where these issues exist.
And it's kind of an endless spiral there, because when you talk about private disclosure, if you want to disclose it only to the defenders, as soon as the net is wide enough, it's not private anymore, right? Say you know about this very severe vulnerability, like this Log4shell vulnerability, and you want to tell the users of it. Who would you tell? It's the world. It's everybody. And so you basically start picking sides. You pick some subset of, you know, maybe you tell the government, maybe you tell, you know, the big infrastructure companies. Like you just sort of pick some arbitrary subset of systems that you think have earned, for one reason or the other, the right to be notified ahead of time, and just because of the blast radius of what happens if those systems get compromised. But as soon as you cast a wide enough net, as you tell enough people, the likelihood of an attacker being amidst those people, and at that point you're giving the attacker a head start on all those people that weren't in your list. And so it's very, very, very tricky. And so really, I don't know, you know, we need some form of registration, but it's going to be, it really boils down to the people consuming open source needing to know which components they are using. And then, because there's no way for a maintainer to notify all those people, there's no kind of single button to run it. That's where potentially vendors or solutions, and, you know, I'm a part of the Open Source Security Foundation. You know, we have been talking about maybe mechanisms of notifications this way, but the tricky part is knowing who's using it. You know, we have a lot of people, for instance, going to us at Snyk and saying, "Hey, I'm a maintainer. I've been told about the vulnerability. I fixed the vulnerability. Can you help me define it and advertise it?" Because they know that we will at least have a certain amount of sort of megaphone to tell the world about it methodically. But I think it's not like there is a clear-cut solution and someone hasn't handled it. I want to note that in this case, the Log4j maintainers, there's been some complaints I've sort of seen on the web around just how quickly they've addressed it. I think they've actually addressed it reasonably fast. We definitely see dramatically worse cases. And so above and beyond the fact that, again, we all owe them a debt of gratitude in terms of the fact that they are for free providing us this great value, they've actually done a lot of good here. And there was no obvious, the only thing they could have done better had they known about it, and it's not trivial to do so, was to manually invest even more time going to, say, the big cloud providers, the big infrastructure providers, the governments, and giving them a head start on it.
And I was going to bring this question up next from Gerald, actually, but you create a great segue into that. Obviously, our open source maintainers, very highly paid, doing this as full-time jobs. Of course, this is while we would like that to be the case as enterprises that are consuming that, it's actually the fact that open source maintainers are getting paid nothing or very little to maintain these open source libraries, because they have other jobs that take their time. And we have to remember that these open source maintainers are not necessarily able to spend as much time as they want. Question coming in from Gerald. So yeah, after this major incident, how the system's broken, right? The system's broken in that we have major organizations, and in fact, not even major organizations, everyone around the world depending on open source libraries that, quite frankly, we assume are bulletproof in the sense that these little things won't go wrong. But we've seen time and time again how small things that you wouldn't actually think were core to your application, pulling down everything because we don't recognize a lot of the time as an industry how critical these are. What can we do to actually, is there a short-term, long-term solution to fix this problem?
Yeah, and I think you have to break down this problem into a few kind of steps, right? The first bit of it is the open source maintainers themselves, and how do we help them build secure software in the first place, and how do we help them fix vulnerabilities as when they are told. And so building secure software is never going to be a perfect case. They're always going to have vulnerabilities. The top kind of best engineering teams out there still write bugs, and some of those will be security bugs. But those kind of top shops, they're oftentimes equipped with technology and training and just sort of safety nets that help them uncover security mistakes when they make them. And so on that part, we need to evolve. Some of this is happening. And again, in Snyk's case, for instance, we provide free tools to open source. GitHub does the same, a variety of others to help open source maintainers assess this. We do need maintainers to kind of pick up the gauntlet. There's a certain amount of they own the project, but as an industry, we need to make it easier for them and provide more and more tooling to help out with that. And so that is happening. And there is also the Open Source Security Foundation. So if you're not familiar, the Linux Foundation has created, actually a good year and a half ago or so, or 2 years ago, maybe even, in collaboration with GitHub at the time and others, created the Open Source Security Foundation called OpenSSF. The pandemic hit, it was a bit slow to kind of get going. Earlier this year, or actually more like mid this year, there was a big recreation of it, or sort of reinvigoration of it. Snyk is a premier member there, as are about 40 other companies sitting on the board, including Google, Microsoft, many other great companies. And the mandate of the Open Source Security Foundation is to help secure the world of open source. There is one project there that is notable called Alpha Omega, which Google and Microsoft are funding. We're part of it, and more, that aims to, on one hand, help the alpha kind of top tier critical projects with actual labor. So Log4j would probably fit the criteria. It's still being formed, but it would probably fit the criteria of literally investing expensive human time or funding the activity for the maintainers, but literal dollars to help secure these open source projects. And the Omega is more about the long tail and trying to figure out how do we indeed make more and more of these tools accessible, as Snyk has been doing, as others have been doing, as the Linux Foundation has been doing with the LFX platform.
Yeah.
So a bit of a long-winded, but that's about helping open source maintainers build secure software and handle vulnerabilities. I just find it very important to separate it from the other side. As open source consumers, you have to acknowledge that you have a responsibility in it. Consumers think that they just use these components and that there's no cost to it. And you have to take on the cost of ownership. You have to invest in tracking which components you're using, in tracking whether they are vulnerable, in establishing remediation paths and the ability to respond quickly. You cannot assume, as you said, Simon, over there, that these, because they are so widely used and because they are so popular, that they are robust. Nothing is bulletproof. All software has bugs. And so beyond the fact that you need to be respectful to maintainers and you need to kind of provide information, and there's a lot of there are many entitled open source consumers out there that think maintainers should just drop everything and do what they've asked them to do. But from a security lens perspective, you need to take ownership and to do it. There are tools to do it. There are many different ways to do this. Some are more agile and empowering, some are less. Clearly at Snyk, we're sort of DevSecOps fans, and our goal is to help still keep developers kind of in the driver's seat and just equip them with the ability to make good decisions and keep track of what they're using. Some organizations go a more rigid route, but you have to accept the cost of ownership of using open source and invest in it. That problem cannot be solved for you by the ecosystem or the maintainers themselves.
Yeah, totally agree. Let's stick with, you mentioned about tooling, you mentioned about Snyk there. Let's actually, as a vendor ourselves, I think we have some insights. We see an impact from how consumers of software are reacting to this. First of all, for those who want more information about the remediation of this type of issue, we have created a cheat sheet, myself and another security researcher, that provide, of course, the ultimate ways of fixing these, which are upgrades. But of course, if you can't upgrade for whatever reason, if you don't have access to source, if you don't have access to pipelines, if it's not your software, but you want to be able to secure what you're running there are alternate mitigations. Some a little bit more concrete than others, partial mitigations, but there's a ton of information there that you're more than welcome to grab. So going into, from the Snyk side, there are some stats that I can kind of like share. Well, I guess actually, before we go into the stats, what's your overall impression been from a vendor side that provides a tool? Obviously, there's a ton of customers who are on paid plans. Snyk has a huge freemium platform with millions of developers using the Snyk tool in their open source and closed source projects as well today. So that's entirely available for people to just come up and use in a self-serve way. They can just go to snyk.io and get started straight away. So what has been, from your point of view, what's the impact of this been from a vendor point of view?
Yeah, well, I think look, fundamentally, first of all, Snyk's we provide value precisely around this area, and so it's a great opportunity for us to deliver value to users, to customers, and before we dig into the functionality or sort of the capabilities themselves, I'm super proud of the team. What we've seen is, basically so many people within Snyk have worked through the weekend tirelessly. As I mentioned before, Snyk's systems were actually secured fairly quickly, and we had a handle on that right away. Really, all of that effort was around helping customers deal with this scenario. We've seen an immense surge in demand. On average, it was 10 to 15 times our typical already pretty high volume of activity, both in sort of new user registrations and in volume of existing customers throwing more of their projects onto our system. We've held the system that is still up. We had a couple of hiccups, a few minutes of API outage or a few other quirks. But generally, we've held well, and so I'm really kind of happy with the team and our opportunity to jump through and do that. At times it was as much as within an hour we've seen a volume of activity that is really a full day's worth coming in an hour. I think it's interesting sometimes about where capabilities kick in, right? So to an extent, a lot of the capabilities we built came into light here in terms of their value. For example, Snyk can assess Git repositories, not just built environments. And we've done that for all sorts of dev experience purposes, but it also means that you can come along and add all your Git repos to Snyk and get very, very quick, immediate visibility. And we've seen that. We've seen sort of customers that originally were on a more gradual rollout path come along and just throw in 10,000 repos into Snyk. To just sort of get this instant visibility. We talked before about transient dependencies. Man, we get so much flack for that when we talk about, when we assess a dependency tree, when we assess an application, it is very important for us to to spend the time, spend the resources, have built the tech to know the full dependencies trees, your libraries and the libraries they use and the libraries they use. It's so easy for smaller tools that come along and they provide a valuable little thing that just assesses the direct dependencies on it. And there's so many conversations sometimes as like, hey, are we doing the wrong thing investing in depth here, right? Are we, should we be spending our time doing something else? And it's like, no. When I make a statement to a customer that they are or are not using a library, we need it to be accurate. And so here it came into fruition, the ease of remediations. So all these different things kind of came to fore. So there's definitely a certain amount of gratifying sentiment of all these investments that we thought were correct were coming into fruition. But really, we're all hands on deck, almost literally, it's like really like across from customer success to communicating like with things like this to of course the product and R&D to just find all the different places in which we can help customers get a handle of the use of Log4j and remediate this problem across all their systems.
Yeah, no, absolutely. And I think it's very interesting actually, because a lot of the time what you want to be able to do is put trust in a tool, right? You want to be able to trust the tool is working, the trust is giving you the right output. And it's interesting, at times, even this week, we've seen more than others, other tools, free tools, really good tools, good tools like Dependabot and others that, are well trusted and they're good tools. They do a great job. But, very often when it gets to the transitive dependencies, for example, Dependabot needs that effectively like a lock file to be able to understand the transitive tree. If you don't have that, you could easily not be seeing Log4j, for example, in your environment. And I think sometimes it takes this kind of a global surge and everyone putting eyes on a specific vulnerability or library's existence in your dependency graph for things like that to really come to light. One other thing I think I always look at whenever we get big vulnerabilities like this, I always, for companies like Snyk, and there's not too many companies that do this kind of thing, but having a freemium platform which is self-serve, whenever big vulnerabilities like this come about, this is effectively like a Black Friday for a retail shop, right? In the sense that the demand that the websites, that testing, that project imports, that user creation gets, as soon as these kind of projects come up, just spikes massively, just because it's so easy to kind of like jump in and test and get that results. And it's so imminent and important that people get that at that time, right? It's great to see how it's played out in the sense of
super valuable. Yeah, exactly. And look, we wouldn't have been able to scale otherwise, right? So if we weren't self-serve, if you needed services from these customers to be able to roll it out to all these different repositories, if you needed to talk to us, in order to get access to the software, you wouldn't be able to scale to all the needs that the community has. And so I think it's a great. There's definitely sort of a sense of accomplishment in terms of like having invested in the areas that we believed to be right, and they were helpful and valuable to us all along, but they're kind of coming to shine over here. I will say that this is a moment for defense in depth. So it was actually really gratifying to see the community, sort of the security industry rally here. Of course, there's business interest for everybody to sort of get mind share and get brand awareness. But fundamentally, everybody's jumping in to help them. And I, for one, will advocate to using all of those different solutions out there. Yes, one is you should use Snyk or choose your choice to identify where you are using this library and patch it. Two is you absolutely should take whatever perimeter security that you might have and use it to block different patterns. The patterns are not as trivial as you might think. They never are. Turns out you can do a dollar curly bracket, J dollar curly bracket, something, and there, lowercase. There's a million permutations of it. But these different perimeter solutions, whether it's the CDNs or the WAFs or the IPSs of the world, they all have a bunch of those. And thinking a little bit about the day after tomorrow, at the moment, I think all eyes should really be on patching the vulnerability, finding all of those doors and locking them. But I suspect next week the conversation is going to be around forensic analysis. Next week the conversation will be around, okay, there is a pretty decent likelihood that damage has been done. What do you have in place to assess whether you have been breached in the process, whether customer data has leaked, whether any malicious agents have been left behind? And so, yeah, right now you have to get a handle on this very, very broadly rolled out open door that might be sort of in your systems. But keep an eye out a little bit around that forensic need you're going to have in a moment.
And let's go back to look, Java's trying to do an update on both systems. That's ironic. Let's go back to struts as well, and because I think obviously struts back in, when was it, March 2017, I think. That was when that happened. Obviously, Equifax several months later announced they had the breach, and in terms of when we should expect to see fallout, you mentioned next week, as soon as next week, in terms of potential for people to say, yes, we were hacked, or yes, we were breached, or this is the activity that we saw. How long a tail do you think this kind of an activity is going to have? And I guess in comparison to struts, what can we look to expect over the rest of this year and into 2022?
Yeah, I think a bunch of things are different here, and pretty much all of them are worse. Well, all of them would, I think, accelerate the level of activity. First of all, struts, as prevalent as it is nowhere near as prevalent as Log4j. It is one framework of many, while pretty much all of them use Log4j. Second, and this relates to the question we had at the beginning around indirect dependencies, the struts vulnerability did require it to be at the forefront, and so there were far fewer systems that needed to be patched. And it was easier to get a handle on where those were, because it was really mostly, it's a big framework. You don't not notice that you're using struts. It's pretty evident for those developers. And so both of those cases mean that the number of breaches that will happen with Log4j is probably going to be substantially bigger. Although, I guess maybe the only counterpoint to that is that struts probably didn't quite get the sort of industry rallying moment that Log4shell is getting. And so maybe we're getting a few points back for that. The second thing that has happened is really around the legislation around breaches and notifications. If memory serves me right, the Equifax breach happened just moments before GDPR kicked into play and others. And so as a result of that, they actually were spared, although they had to pay a fairly significant fine. They were actually spared an even bigger fine from not notifying users ahead of time, because there was I forget the exact timelines, but I think it was about 3 months gap between the notification, between the vulnerability getting disclosed, the time in which they found it and fixed it, and then another 3 months until they've actually made the public notifications, or at least a longer period of time. Today, they would be fined by GDPR and the kind of equivalent law in California, and a few others now would fine them substantial amounts that I think are full percentages of their annual turnover for such a breach. And so at the end of the day, I think there's the immediacy and there's the long tail that you asked about. Immediacy, I think we will probably start seeing disclosures around breached information soon. I would guess definitely on this side of the year, definitely before the end of the year. It's just that everybody's attention is on plugging the holes, so they haven't been digging into it. But I think it would only take a few more days or so before you start hitting those timelines in which legislation requires you to notify them. And definitely certain breaches have occurred. I'm definitely aware of some. I'm sure there are quite a few. And then the long tail of it would be a long while for again, several reasons. One, it might take a while to find out you were breached. The smart attackers will come in and plant themselves elsewhere in the network now, knowing that there's a lot of eyes on this problem. So some of those will come after, and it might take a while to realize that you're breached and you've done it. Some companies would still be slow to disclose, but also this vulnerability is not going to go away. This old library is still going to be embedded in all sorts of components. We think about servers that we can patch and roll out, but there's also devices. Every Android device out there is sort of building on Java. There's so many devices today, in the IoT world that rely on Java, and many of them in turn use Log4j. And so all of those devices are rolled out, and typically those devices do not have quite as capable an update mechanism as we've seen before. And so this vulnerability is going to be with us for the foreseeable future, and I think you'll see it play a role in breaches definitely throughout next year, and it'll probably become a part of the common flaws that we might see for a few years now.
Yeah, and it's interesting actually you mentioned the sheer number of devices, because I know Oracle and other companies, obviously big companies behind that back and support Java, are always saying how many billion devices, etc., running Java, which is always kind of like a big brag, and it's nice to see how prevalent Java is. But now those kind of stats are absolutely frightening in terms of trying to understand how many hundreds of millions of devices, etc., could potentially be.
Yeah, and this is the intended, again, I just can't stress that enough, is this library is used to log, and it is extremely likely, like you don't log fixed information, you really almost always aim to log some amount of user input. And so anybody using this library is likely vulnerable, or at least a very, very high probability. It's not like it's some side functionality. The JNDI thing is, but the function of logging is the sole reason that you would use Log4j. And so, not only would it be a vulnerability, it would actually be an exploitable one in many places.
And this kind of an attack, this kind of a vulnerability, we mentioned struts as something which people are comparing it to. SolarWinds is another one which I've heard, although that's kind of slightly different in terms of that being much more of a broader supply chain issue, right? Going forward, so first of all, any comparison that you want to make on that, but going forward, what can we expect in future? We've seen a number of, in the JavaScript world and other places, lots of different types of vulnerabilities in and around third-party libraries. But what are, is this our greatest threat these days, or is it anything more about, there was a lot of talk around misconfigurations. There's a lot of talk about the broader supply chain, not just the libraries that we're using. Is this, I guess, the biggest threat, or something else?
Yeah, I mean, I think SolarWinds, just sort of get that off the table. I mean, I think it's a very different type of attack. But at the end of the day, I would say Log4j Log4shell is a worse scenario in terms of its eventual impact, just because SolarWinds, again, nowhere near as prevalent as Log4j, and dramatically better, more trackable about where you are using it, and so both of those make it hard. Very different, because that one, it was a malicious attack versus this one, which is a vulnerability. But all in all, I'd say impact on the industry of Log4shell is a lot higher. The future for it, I think open source is like a little bit like nuclear power, right? It's amazing, but when there's a meltdown, it's pretty harmful. And so we have to think about where do we harness this energy? We're going to use it. That's going to keep up, and it's a great thing, and we don't want that. We don't want to reduce the pace of innovation. We all thrive on sort of that evolution. But I think where this will head, there's mini versions of Log4shell happening every day. The either vulnerabilities that are as severe but not as prevalent, or maybe sometimes not as exploitable, or vulnerabilities that are not as severe. They're sort of a smaller information disclosure or denial of service type issue, but they're just as prevalent in libraries that again have very, very, very wide reach. That's never going to end. This is software, and the same multiplier that you get about the value. You take Log4j, it's providing a great piece of functionality. Just the number of developer days, developer years, developers decades that have been spared by this library existing is tremendous. Provided so the multiplier on every bit of any character in the Log4j code in terms of value provided is insane. It's very, very high. At the same time, every mistake there, sometimes a functionality bug, but definitely security bug, has just the same multiplier of reach and those paths. And so I think when you kind of cast your eyes ahead, it really is around evolving our maturity as an industry and as organizations in how we manage open source. There's definitely a standards body element to it. So in the OpenSSF right now, again, a lot of sort of great companies contributing things, Google being definitely at the forefront there. There's the SLSA, sort of SALSA framework, the scorecards objects over there. There's definitely a lot of work. There are two somewhat competing, but still good standards in Cyclone DX and SPDX, both trying to define better ways to describe open source components, to say, what do I know about this open source library? Construct indeed a software bill of materials to define it. So we need a shared language, so that when we talk about a component, we talk about what you're using. It's there, and then we need an element of ownership that comes from the consumers of open source. So if on one side you kind of had the open source community, the OpenSSF, on the other side you need to have maturity in tooling and practices of organizations that embrace open source. I'll say up front, if you're a CXO and you think you can now control and only allow your developers to use these 7 whitelisted libraries, that's not going to fly, because that would go against the need of the business. The business needs agility, it needs speed, and so you can apply some constraints, but the way the world is going, that's not going to change. Innovation and the need for business is going to drive our activity more than security. And so you have to think about investing in tools, Snyk being one of them. There are others, to track your software bill of materials, to know which components you're using, to be prepared to run scenarios and mock incidents around cases like this, to see how well prepared you are. And there is a bit in the middle that's more SolarWinds esque, which is the notion of the literal consumption and avoiding tampering with the supply chain, so that when you are consuming a library, you're actually like the library you are consuming is indeed the one that you've intended to, which is its own kind of a set of threats, which has a combination of some open source solutions needed and some commercial products needed. But I think at the end of the day, the evolution is only around like evolving how well we allow organizations to own open source, and then supporting open source maintainers in securing what they build on the other side as a community.
Yeah, and I think, a comment here from Davis Peter: asset management is key for such 0 days, and I think asset management is key. And I think there are multiple ways of actually getting to this, and a couple of ways that you described there. One where you have a security team which pretty much mandate a blocking process where you need to go to a security team to request a certain asset, and then that gets added into maybe a artifact repo or something like that for you to then use. I think what we've seen, and I'm probably talking more anecdotally here over the last few days, but what I've certainly seen is organizations that do have really strong asset management have just been able to get on with fixing, and not just asset management in terms of, yes, we know we are using this somewhere. It's about having asset management whereby two things. I think, first of all, scaling that knowledge of your asset management through the development organization allows them to actually capture all the assets that they're using, rather than just assets that a security team think they're using. But the second thing really is having the information consumable by developers, so that they know not just that they're using the asset, but they know where they're using the asset, the role the asset has to play in the overall application architecture. And I think anecdotally, I'll say what I've seen is the people who have gone through this with the fewest amount, the least amount of pain, are those that this was kind of like business as usual anyway for the developers. Because a lot of the all-nighters, it's not just security teams that are doing this. The development teams are doing the all-nighters. The development teams are working the weekends. And it's just so telling how those with those very established working DevSecOps practices, it was almost business as usual, but at a very elevated level. They're not learning new techniques or learning new things. It's just putting in place all the things that they've set up over time. Any comments on that kind of things that you've seen in
No,
the course of
absolutely. Yeah, absolutely well said. I mean, again, the world is becoming more and more agile. That drives innovation, just like open source. You can't fight that. That's the way you become competitive. That's the way you increase the value you provide to your customers. So you have to lean into that, and you have to think about how do you build these security practices into that day to day. How do you build open source ownership into that, and make it a part of you. Build it, you run it. You own the components that you pulled into it. You own securing it, and surrounding it, security teams and the industry and the platforms need to equip you, the developer, equip developers at being successful at that mission. So yeah, but very, very well said. In general, there's a whole other narrative here, which is around in various cases reducing your assets. This has definitely been a play in demonstrating the value of SaaS. If you are running an application right now, that application might be vulnerable. You need an updated instance to it. There's a bit of a daisy chain there of waiting for an update from a vendor, and so there's definitely an element of that. And similarly, if you are using platforms that obviate, that maybe like remove. In the case of Log4shell, it's at the Log4j is at the app level. So that's a bit different, in Shell Shock. And for instance, if you were using serverless, which didn't exist at the time, but today, the platform might have addressed that for you. And so, those are two other interesting motions around reducing the assets that are within your domain and within your management.
Very interesting. That was exactly the parallel I was going to draw, actually, with the serverless shared responsibility of a serverless platform versus something else. Indeed. Well, Guy, we're at time, so a big thank you. I've really enjoyed the chat as always. Thank you very much, and thank you to the audience as well for your comments and questions. We'll see you again on the next Snyk Live on the Log4shell series or elsewhere. And thank you for joining this Snyk and DevSecOn presentation. Thanks all.
Indeed. Thanks, Simon. Thanks, everybody.